second part of R4 where we were talking about factoring. We're going to continue talking about factoring, but first starting off with a little warm-up to review our exponent rules. So here we have all of this stuff squared. So go ahead and write that down. You're going to hit pause to write it down, give it a try, and then come back and check to see if you have those exponent rules correct. So if you distribute the 2 first to everything, you have x to the negative 6th, y to the negative 4th, over x squared, y to the negative 8th. Then you can subtract, and you'll have x to the negative 8, y to the 4th, and then we want to get rid of the negative. So remember, things that don't have a negative stay put. So y to the 4th stays where it is, but things with a negative need to move. So y to the 4th over x to the 8th. All right, so last time we factored where the leading coefficient was 1. Today we're going to look at when it's not 1, which takes some more steps. It's called splitting the middle. So notice that our leading coefficient here is a 2, so it's not a 1. Anytime it's not a 1, you have to use splitting the middle. What we do is we start by multiplying this leading coefficient times the constant. So 2 times 8, which is 16. We want to find things that multiply to get 16 and add to get negative 17. So the same kind of idea as what we were doing before, but before we didn't have to worry about that first step of multiplying because it was a 1. So 2 times 8 to get 16, things that multiply to get 16 and add to get negative 17. All right, so what multiplies to get 16? Well, we have 1 and 16, 2 and 8, 4 and 4. If we add those together, 1 and 16 equal a positive 17, but we want a negative 17. So that tells me I need the opposite. So negative 1, negative 16 would give me a negative 17. Now, we can't just take those and plop them into the parentheses like we did before. Now we have to actually split the middle. So this is the middle. Negative 17x is the middle, and we're going to split it. Instead of having negative 17x, we're going to have negative 1x plus negative 16x. And those could be in any order. You could put the negative 16 first, or you could put the negative 1 first. We just take the two numbers that we found and use them to split the middle. The leading coefficient stays the same, or leading term, so we just drop it down. 2x squared just comes straight down. 8 stays the same, so it comes straight down. And you'll notice we went from a trinomial, or 3 terms, to a 4-term polynomial. You might remember from our other factoring lesson that when you have 4 terms, what factoring method do we use? Grouping. So we're going to group these first 2 together. What's common? An x. So 2x minus 1 is left. Group these next 2 together. What's common? Well, you'll notice that there's a negative here, so we have to take that negative out. So negative 8, that leaves us with 2x minus 1. Notice the parentheses match there. So now we have a GCF of 2x minus 1 that we can remove, and x minus 8 is left. All right, so that's the splitting the middle process. So go ahead and write down number 9 and try that yourself. So take a minute, make sure you pause the video, and start from the beginning. Multiply the leading coefficient times the constant and work your way through. All right, so 6 times negative 6 equals negative 36. So I'm looking for something that multiplies negative 36. And then it has to add to get a negative 5. Whew, so factors of negative 36, there's a bunch. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. All right, so do any of those equal negative 5? Oh, negative 36 means that one has to be positive and the other has to be negative. So if I make all these first ones negative, that would make these all equal negative 36. So now do any of those equal, when we add them together, equal 5? Well, negative 4 and 9 equal a positive 5, but we want it to equal negative 5. So if I switch those signs and have a positive 4 and a negative 9, that would give me a negative 5, and we would still multiply to get negative 36. So you can kind of see how I'm thinking through that. Some people can just find those factors right away. Others, it's helpful if you make a list and kind of reason through what has to be positive, what has to be negative, so we can have the right combination. So 4 and negative 9 would give us a negative 36. They would also add to negative 5. So those are the two that we're going to take to split our middle. So negative 5x, and we're going to have a negative 9x plus 4x. Drop down the last term, drop down the first term, and now we have 4 terms that we can use to split the middle. I'm sorry, factor by grouping. So group the first two together, common 3x, that's our GCF. 2x minus 3 remains. In the next two, we have a GCF of 2 with a 2x minus 3 left over. 2x minus 3 is the same in both, so we can factor that out. And we have 3x plus 2 as our second binomial. All right, next up, we're going to look at a different factoring method, which is factoring a difference of squares. A difference of squares. So difference, that word in math, means subtraction. And squares, we're talking about something squared, so like x squared. So this means that we are subtracting two things that are squared. So the formula that we use for this, a squared minus b squared. So you'll see that we have two things that are squared and we're subtracting them. So difference of squares. Those problems that are set up that way always factor to the square root of a squared, which is a, minus the square root of b squared, which is b, and then times a plus b. So, several things to think about when you encounter a problem. If it only has two terms, it's possible that it's a difference of squares. But we have to go through all of our kind of factoring knowledge. Start with the GCF. So you always want to do GCF first. So is there anything common here? Yes, they both have a 2 in common. So we're going to start by taking out that GCF. Next, we want to look and see, is it a difference? Are we subtracting? Yes. Sometimes we'll put a addition sign here and then we can't use this pattern. So make sure it's a subtraction sign. Are both of these perfect squares? Can you take the square root of them and get nice answers? Yes, you can. Square root of x squared is x. Square root of 9 is 3. All right, so that means we can continue on. The 2 GCF stays on the outside, and then you take these square root values, the x and the 3, and you write them as x minus 3, x plus 3. All right, so give it a try on number 11. Check for a GCF first, then check to make sure it's subtraction. That's an easy check. Then take the square root of each one and rewrite it. All right, so there's no GCF that's common between those two, so there's nothing to take out. If I take the square root of 25x squared, that's 5x. Square root of 16 is 4. So when I rewrite it, it's going to be 5x minus 4, 5x plus 4. And that's called the difference of squares. All right, the last thing we are going to look at in our factoring lesson is the sum and difference of cubes. Okay, so we just did the difference of squares. Now we're going to do the sum and difference of cubes. You probably know that sum means addition. Difference, we just talked about a minute ago, means subtraction. And then cubes is when we have something that is cubed. So there's two different options that we can have here. Let's start with sum. So it means we have something cubed and it's being added to something else cubed. Similar to when we did the squares, we have to find the root. So you would take the cube root of each of these, which in this case would be a and b, and it starts with a plus b. The second parenthesis is a squared minus ab plus b squared. Now you may have heard an acronym that helps remember the signs on this. It's called SOAP. SOAP tells us that when you are doing the sum and difference of cubes, the first sign is the same as the original. So our original was a plus, so our first sign is a plus. So S stands for same. The next sign, the O, is opposite. So you'll notice that the first was a plus, the second was a subtraction. So we have addition, subtraction, those are opposites of each other. And then the last sign, the AP goes together, is always positive, no matter what. Always positive. So keep that in mind when we do the difference of cubes. So we also have the option where we have two things that are cubed that are being subtracted. The setup is very similar. So we take the cube root, and using our SOAP acronym, the first sign is the same. So since this was subtraction, we do a minus b. Then we square the a. The second sign has to be the opposite. So since it was subtraction, now it's addition. A, B. And then the last sign is always positive. All right, so we're going to use one of those to simplify or factor these next couple problems. All right, so we have x cubed minus 27. Like with all factoring problems, you want to check for a GCF first. Is there anything common between both of those? No. So there's no GCF to take out. So then we can jump straight to the sum and difference of cubed factoring method. We want to take the cube root of each one. Cube root of x cubed is x. Cubed root of 27. What multiplies to get 27 if you multiply it 3 times? So have to multiply it times itself 3 times to get 27. Well, that would be 3. 3 times 3 times 3 is 27. All right, so we're going to use x and 3 to build this factor. All right, so since it's subtraction, we would start with x minus 3. That's the same sign. Now the next thing says to take your a, that's our x in this case, and square it. So we'd have x squared. The next sign should be the opposite. So we'd put a plus sign in there. Then it tells us to multiply our two cube roots together. So I'm going to take x times 3, which is of course 3x. The last sign is always positive, and I'm going to take the b part and square it. So here's my b. My b was 3. So I'm going to square it, so that's 9. So x minus 3 times x squared plus 3x plus 9. All right, so go ahead and try number 13. I want you to pause, write it down, go through your factor steps, check for GCF, then take cube roots, and see if you can write it out using that factorization pattern. All right, so this one does have a GCF. 2 is common between both of them, so we want to take out a 2 before we begin. 16 divided by 2 is 8. And then 2 divided by 2 is 1. So the 2 just kind of stays out to the side for a minute. We're going to take the cube root. Oh, goodness. This should be a cube. Cube root of 8x cubed. So the cube root of 8 is 2. Cube root of x cubed is x. Cube root of 1 is 1. All right, so let's try to write it out. The GCF of 2 stays on the outside. My first parenthesis is going to be 2x plus 1 because our original was an addition. Then I'm going to take my a value and square it. So I'm going to square 2x. I have to square both of them. So 2 squared is 4, and then x squared. My next sign is the opposite. So it was addition, now it's subtraction. My next term, I multiply these together, 2x times 1, so it's 2x. My last sign is always positive, and then I need to take that 1 right there and square it, which is 1, to finish it off. So 2 times 2x plus 1 times 4x squared minus 2x plus 1. Once you get the pattern down, piece of cake. So just make sure you know the patterns for that sum and difference of cubes, and you'll be good to go.